and today we are actually going to be solving them, which, if we have retained any information from when we did graphing inequalities before, um, we should be more than okay with this stuff. So there's essentially two steps to graphing these things. If you're taking notes, I wouldn't worry about the steps right now, um, just because you could write them down another time. And again, I think memorizing steps is worse than just understanding what makes sense and what to do, right? But step one is just graph each inequality, shade it correctly, and then you just have to identify the region where both are shaded. And so, maybe as a quick reminder, um, to graph these things, all we have to do is graph the line as if we had an equal sign, and then there are two extra things we had to do. We had to do solid or dotted, and then we had to shade above or below. And so if I am looking at this first one here, maybe I'll do it in red, y, and then if I pretended this was an equal sign, 1/2 x plus 3, again, this is slope, this is the intercept, so plus 3, I'm going to go up to 3 because that's my y-intercept. My slope is 1/2, and if we remember, graphing a line, we do rise over run, or change in y over change in x. So rise is 1, so I'm going to go up 1, and I'm going to go to the right 2 because run is 2. Rise 1 over run 2. So up 1 over 2. And I'm going to the right after I do that because I want a positive slope, so I want to be going uphill from left to right. And I'm going to plot a few extra points so it's easier for me to graph up 1 over 2, up 1 over 2. If I went this way, I'd have to go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. And then we'd sketch our line, and delta math makes it easier than it will be for me. But remember, since it's just less than, we have a dotted line. Hopefully this is bringing back some memories. And before I do the shading, I'm going to go and I'm going to graph this line. So y is greater than -4. That might be a tricky one. We need to remember that when y equals -4, that's a horizontal line this way, and it's also dotted because it's just greater than. Now, we need to understand what's going on with the less than and greater than. So remember, we would use to shade these, and so when we shaded these, for this red one, if we said y is less than 1/2 x plus 3, that means we want all the y values less than this line. So all the y values less than this line are going to be underneath. So that would shade everything underneath. And then for the blue line, y is greater than -4, you want everything above. You want all the y values above this line. So we would shade above for this line. And then the difference is now, instead of just having one, now we have two of them, and the solution is going to be where they're both shaded, which in this case is this little section right here that I'm going to shade in green. That's where they both end up being shaded. And delta math makes you state a solution in there. So remember, a solution to a system of equations is a point, much like the solution to a system of inequalities is also a point, but it's usually typically with inequalities a bunch of points, right? It's going to be any of these points in here, and this is going to extend on forever, right? It's going to be this little triangle, this infinite triangle that just keeps going. Any of these points in this green space would work. So I'm just going to pick one that I know works. 8, 5 looks good, so 8, 5 is in there. Yeah, what's up? The green part or just any shaded part? Okay, so um, good question. So once you graph these lines and you choose solid or dotted, so this red dotted line here, right, was the line 1/2 x plus 3, and we want this is saying you want all the y values less than that line. So if you look at this line and you ask yourself where are all the y values less than this line, they should be below, right? And I guess one trick to do is you could pick a point on the line, right? So here we're at y equals 3, and we want the y values less than. Is that going to be above or below? Obviously, that's going to be below. And so here's all the points, all the y values less than this line. Is that helpful, Sandra? Yeah, so 1/2 x plus 3 is just going to be this line because it has a y-intercept of 3 and a slope of 1/2. This y is greater than -4, doesn't have a slope, so it's not going uphill or downhill, it's flat, right? There's nothing with an x, and its intercept is 4. Oh, it should be -4. It should actually be -4, right? So same idea, but we just have to change it just a little bit. Yeah, you just have to look at the intercept and the slope. So actually, -4 is down here, right? I messed up, but it's the same idea. Doesn't matter because then you would shade above our solution set is now it's just going to be a little bigger, right? It's going to be all this stuff in here, which 8.5 still works. So we're good. Yep. So you would just have to sketch that line first, and then if you're having trouble with the slope with the rise over run, remember -3 is the same thing as -3/1. If that helps. Which we can kind of get to one here. So this one, if we graph this line, we have 6 is our y-intercept, and then we just have a slope of 1, so up 1 over 1, up 1 over 1, up 1 over 1, or down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And this one is solid because it's or equal to, so we have a solid line there. Now we can do this one. Our y-intercept is at -4. And then we have a slope of -3/2. Remember, rise over run for our slope. So at this point, I'm going to go up 1, 2, 3. But now I'm going to go to the left 2 because we have a negative slope, and I want to be going downhill from left to right. So up 1, 2, 3 over 1, 2, 1, 2, 3, 1, 2. And then this line is dotted because it's just greater than. Now I can shade. So this red line, I want all the y values less than or equal to this line. So that's going to be all the y values below. Right? And now y is greater than this blue line. So I want all the y values greater than this blue line. So that's going to be everything above the blue line. And delta math shades it nicely for you. And then we want the double shaded area, right? So we want where they're both shaded or in this green, right? And it's the same concept as the equations, right? When we had a system of equations, we had when we solved it by graphing, we would graph two lines, and then we said their solution was where they intersected. It's kind of the same thing here, right? It's this intersection because we're asking, okay, all this red shading is what makes this inequality true, and all this blue shading is what makes this inequality true. So what makes both inequalities true is where they're both shaded, or the overlapping of the shading. So that's like the conceptual idea behind it. And then it asks us to put state the coordinates of a point in the solution. So literally anywhere in this green stuff, 6, 0 looks like a good one. You know, right? There's a million different ones you could pick. You could pick 9, 3, right? It even looks like we could pick, you know, I don't know, -1, -1 if we wanted. As long as it's in this green shaded area, you are good. Any of those points will work. Okay, let's go through probably one more. It's 11:27. Yeah, we can get through one more. So, problem with these ones is we don't know how to graph these unless y is by itself, right? If you're looking at it and your brain starts like your gears kind of stop and you know you're drooling out your mouth a little bit like, oh, what do I do? It's probably because you can't do something, right? If you're looking at this like, how do I graph this? That's a great question because you can't really graph this until y is by itself, right? So we have to get y by itself in both of these. So I'm going to subtract 2x over, right? So then I get y is greater than or equal to, and I'm just going to write the negative 2x first, plus 3. All right, so here's one equation. Maybe we can start and graph this one. Y is greater than negative 2x plus 3, so plus 3, we're at ay intercept of 3. And then negative 2 is the same thing as negative 2 over 1. So if we do our rise over run, that's up to the left one, because I want a negative slope going downhill. So up to the left one, up to the left one. Or we could go down to the right one, down to the right one. All right, and this one is going to be a solid line. And it's supposed to be going through those points, but that's good enough. It's supposed to be going, and it's a solid line because it's or equal to. And then we have the same problem with this other one. Y is not by itself. So there's a couple different ways to solve for y. I'm going to go one way, subtract that x over, so we get negative 3y is greater than, and I'm going to put the negative x first, plus 12. And now negative 3 is in the way, so I'm going to divide by negative 3. When I divide by negative 3, I have to divide everything by negative 3. And now here's where we have to be careful. We went over properties of inequalities before. When we multiply or divide by a negative number, this inequality has to switch. So we need to remember the stuff we learned previously. Since we divided by a negative number, this inequality has to switch. Negative divided by a negative is positive. X divided by 3, I can write that as 1/3 x. I can just put that x out front and leave a 1 up top. All right, because negative x is really the same thing as negative 1x. And if I'm multiplying, right, I can just throw it outside. So that's going to help me graph it. And then 12 divided by negative 3 is negative 4. And now we can graph this one as well. So we're at negative 4. And then we have a slope of 1/3. So up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Down 1 to the left, 1, 2, 3. And again, I went this way because I want a positive slope, so I want to be going uphill. And this line happens to be dotted. Okay, and now I'm going to do the shading. So y is greater than, here's our red line. We want all the y values greater than, so we're going to go above this line. All right, here's all the values above. And now for the blue line, we want y is less than, so we want all the values below this blue line. So we're going to go under. And then we want the area where both of these inequalities are true or where they are both shaded, which is right here. And then it asks us to put a point in there, and so we just have to pick any of them. I don't know, 8, -4 looks pretty good. So 8, -4 is a point that works, right? But there's a bunch of points that work. And also as a reminder, this solid line is representing or equal to, and this dotted line is when there's not or equal to. What that means is that the points on this line make this inequality true, but the points on this line don't make this inequality true, right? But everything just under this line does. So when we shade, technically right here, this part of the line right here, these points also work. Because this is a solid line, so these points are included, and it's shaded here. But here, since these are dotted, they're not going to be overlapped, right? The red goes here, but since it's dotted for the blue, it's not included there. So all the points on this line are included in the solution to both of them, but not the points on this line.